Hey, my camera just, cut himself off, so I cannot show my lovely face to you. Sorry about that. But thank you, Rebecca, for a very nice introduction to the ECAD MCAD collaboration and why does it matter. Summary, now it's coming. So if we take a look at a bit of history view on this one, so what's been out there for, let's say, decades is the founding blocks of the ECAD MCAD collaboration. At the late 90s, early 1990s, and let's say turning of the millennia, we had already kind of all the basic standards in the place to basically to facilitate the data exchange between the mechanical CAD and the electronics CAD. So if you take a look at the, let's say, Pro ECAD product that kind of emerges at the late 1990s, you could already then bring in the kind of a key components from electrical design, make them visible in mechanical CAD, and starting to collaborating and discussing whether there's interferences between the components or if the bill of material should be in the mechanical CAD or the electronics CAD. So it's quite a long way ago, over 20 years. And over the years, we have refined our technology, make it more and more mature. And today, you really can't tell on the top right image if that is from the mechanical CAD or if that is just a photograph of the actual component. So we are able to really nicely today exchange the product information from one kind of a domain to another, thus enabling kind of a cross-functional team to work. Next slide, please. And if we take a look at how does the actual data exchange happening between the electronics CAD and mechanical CAD domains, we today have text files, which we push back and forth, and they describe the products at the both end of the system. And that has been there for good kind of amount of years. But on the other hand, if we're looking at this like way it's been managed to face it to the work, so if you just write out the ECAD files to a kind of a disk and then read them in, this leaves a lot of room for improvement when it's come to make sure that you always have the latest version of the data at your hand. So next slide, please. Today, in the PLM system, we can of course introduce new parts. So we have vendor parts, manufacturing parts, we have all the data sheets when you create an items. Click again. And then you have all the altering applications in the PLM system. So today you have the mechanical CAD in there, and then you have the electronics CAD in there, and you can collaborate them back and forth. And then, of course, since we do have a PLM system, we have all the goodies of the product kind of fun, change management, all kinds of things like collaboration. We have a component of supplier management in the PLM system. And at the last, we also have ability to distribute the data outside of the enterprise and also make sure that our products are compliant. So PLM is really kind of making it possible to collaborate on the kind of one platform between the ECAD and MCAD domains. Please go on. So today, if you look at how does it look like when it comes to ECAD MCAD collaboration, we are still pushing, let's say, text files via PLM back and forth. The systems, we always know that what is the latest version of the files, and it really is kind of a mature technology that works back and forth. Next slide, please. And if we take a small video and take a look how does it look like really? We have the same PCB that Rebecca just showed us. And if you go for different visualization formats of it and open them in the same Creo view system, then something magical starts to happen. So first you open just a mechanical kind of a model where you can see all the components. And then additionally, we will add some more information to here. As you can see, when you say open to Creo view, you can add it to the same session. And thus making all of those three viewables available for you. And in here we have some, drawing for the particular. And here we have a kind of a layout, where you can start controlling. Do we have a logical connections, or do we actually have the routing or the conductors between the components? and do we want to see the printed silks and all that kind of a component information. Just filter based on your needs. And then you can have them side by side, which of course it makes it quite handy to understand what is exactly happening here. So now when you start clicking around, you can enable so-called cross-highlighting. So one clicking component in somewhere, it's always updating the information on the other windows. So let's see. As you can see, clicking that component, it will highlight on the other window. So it's getting a bit easier today to probe the kind of product and to find out that what exactly is happening here or what is the design. And when it comes to collaborating thoughts, if you have a, let's say, geographically distributed design environment where the, let's say, electrical design is the United States, but then the mechanical is at the Europe, then of course what we want to do sometimes is to write notes back and forth, and in order to somehow document the changes or document the requests. Can I move, for example, this one a bit? So what I do is save an annotation set in the model. Write some kind of a comment like, please change this one, or can I change this potentially? Store it, and it will be stored on the windshield on the product information. And of course, you can share that one for your teammate and ask it kindly that would it be possible that you change this one? Please take a look at the link, and when he opens it up, it opens up exactly the same for him as well. So it's enabling really nicely about the collaboration between the things, between the domains. And of course, next slide, please. There's some obvious benefits from this system as well. So PLM really enables you to have a cross-disciplinary design. So one kind of a data location where the master is always stored, and then of course make sure that you can distribute the data for the manufacturing and have the complete product information with you. Next one, please. But if you take a few steps to the future, what it might look like. So far, we've been just having a ping pong between the files in the system. Please, next slide. But how about the future? What will the future hold for you? So let's take this role of that we have a Paula, and she is a PCB designer, so designing the printed circuit boards. Initially, what she does is just collect most of the key components and just some kind of fun sketch of the rectangular big black PCB and stores that to system. So this is just the initial. Okay, this is what I might require to make a product. But then the mechanical engineer, comes to the working place and starts doing his daily job. And one of the things is that what he can do is to connect to the ECAD system alongside the windshield. Take a look at what are the current kind of products that are going on the design, and then just simply connect it directly to ECAD data via server. Then some display manipulation. As you can see, all the components are already available for him, the mechanical engineering kind of a domain. Then what we do next is add, let's say, covers for the product. So in here, some kind of casing, which come from the industrial design team, I believe, and just place it on his mechanical design and start manipulating then the design so that it will fit for the purpose. So first thing to do is, of course, manipulate the board layout so that it actually will fit in the enclosure room. Using just basic modeling operations, we will now make sure that we are able to make the board holes in there, general form, fits, and functions for the board size and shape. And then we just simply drag the models and place them on the PCB board so that mechanically the design is valid without really consulting any of the electronic design, but something that makes sense in the mechanical world. And then at the end of the day, what we do we will check in our design or push it in for the PCB designer to be amazed of, okay, this is how the mechanical team is seeing the situation, and thus starting the collaboration between the different design teams. And when the Paolo, of course, opens up the design, which he made originally, she can see that some of the components has been changed, some of the location has been updated. She can now either accept or refuse the changes, either one by one or let them all come in. And then servers keep taking care of the actual location of the components and everything is used. And now from this point on, she can start her work with the design. Next slide, please. And if we take a look at this one, the server page approach, of course, this is as efficient as it was, with transfer files. But of course, what we can do in here is accept or reject the changes with the previews and everything, and all the history of the iteration history is kept for the later reuse, or let's say if we have to go back for some decisions, why did we make it like that? We have some starting point for that discussion anyway. Next one, please. So what I see is that after this small history introduction is that when we come from the file-based back and forth, kind of sending out and writing in the files which kind of describe the PCB data, we are coming from step by step toward the actual server-based design, where we have all this kind of a design domains on the same PLM, and thus enabling us to really make it nice and complete product description in there.